something strange here.
Okay, yes, we are recording now.
Okay. I have this little thing displaying on my screen, which I don't want. Okay. I'll just shrink all these little windows down here. I tried lowering my resolution, so hopefully it displays better. So my name is Jim Pick, and I work at Protocol Labs. I work on the dynamic data and capabilities team, and we build some framework and applications that work with IPFS. And our primary showcase product is called PeerPad, and I'm using PeerPad. It's a collaborative text markdown editor, and I'm using that to store my notes here. So I'm just going to share the link here for anybody who wants to join in the Zoom chat. Oh, I think I have to stop the share to do that. Okay, sorry about that. Okay, did everybody see the screen?
Yeah. Okay.
So I just wanted to do sort of interactive at the command line tutorial. Is that what people would be interested in, to get a quick feel for what IPFS is?
Yeah, I think that would be super helpful.
So before I do that, I think I'll just quickly pull up the website for IPFS. So I don't know how familiar everybody is with it, but this is the main website for it. And it says IPFS is the distributed web. It's peer-to-peer hypermedia protocol to make the web faster, safer, and more open. And there's a fair amount of marketing material here. So IPFS, we're calling it distributed web or decentralized web, but at the core of it, it's a system for transferring files around. So in a lot of ways, you can think of it as a peer-to-peer protocol, similar to, like in the old days, there's BitTorrent, which people use for downloading files. And it's it's using similar technologies. But instead of having just like trading individual files, like movie files, people can run IPFS instances on their computers, and it will store all their files, and they can share their files with everybody in the world. And it's sort of a global file system. So let's see. And I don't know if there's really, I'd recommend just going through here. There's some introductory material. And I'm going to just skip past all of this. So what I want to do is demonstrate the IPFS command line. And I would go to get information, to get started with this, I would go to docs.ipfs.io, and they have your basic IPFS documentation. What is it? And importantly, how to install it. There's several different versions of IPFS. The one I'm going to be showing today is the command line, and it's a program that's written in the Go programming language, but it's distributed as a binary, and you would just get the pre-built binary for your system. So I'm running this on a OS 10 Macintosh system, so I'll just pull up my thing here. So I already have it running. Let me see. I'm just going to shut it down. So what I was showing there was the IPFS desktop. I just want to show the command line. So if I do or which IPFS, you can see I have the binary installed in this location. Before going any further, is this about the right level? Are people comfortable with the command line?
Yeah, I think that makes sense to run through.
Okay, so I've essentially installed this using the instructions. And if you type just IPFS by itself, let's make this a little wider. You can see the help information. So called P2P Merkle-DAG file system. And I'll show you, I'm just going to, it stores all the data in a directory in your home directory called IPFS, but I'm just going to move that out of the way for now. So if I go IPFS right now, ID, because there's no IPFS repo. So the first thing you have to do is run IPFS init, and it will create in this directory here a .ipfs directory, and this directory will store all the files you store in IPFS. So in some ways, it's a bit like a database. And the other thing you'll see when I ran it was it generated a key pair, and this is basically the public key. So this will be used by all the other peers in the world to find your IPFS peer, and it's basically your address. So and they say to get started, enter IPFS cat, and then what we're seeing here is this is just sort of a path that tells IPFS that this is how to look it up to use the IPFS protocol. And this is what we call a content ID or a CID. And I'll get to that. So let me cat this file here. And there. So what just happened here was this file, this is a text file. This text file did not exist on my computer. It went over the network and it found other peers and loaded this over the network and brought it over, copied it onto my IPFS node, and I was able to output it to the command line. So right now I'm not actually, so if we're in IPFS command line here. So far we've used the init command, the IPFS ID will give you what we saw previously, the peer ID. And the peer ID is a shortened version of this public key. And there's a private key, but that's sort of hidden in the system. So does everybody follow along with what you've seen so far?
Someone just responded in the chat and said yes.
Okay. So yeah, I can't see the chat when I'm sharing the screen. So this is pretty easy. But what I'm not doing right now is IPFS isn't actually running. So I'm just using it's just firing up, talking to the network, pulling files down. But normally how you use IPFS is you run IPFS in a daemon mode. So if I run IPFS daemon, it will actually start up. And it starts listening on several ports on your computer. So it's listening on port 4001 and also on port 5001 and port 8080. So it's opened up a bunch of different services it's providing. So what that lets me do is I can go in another window, and for an IPFS ID, the same as before, but now I can talk directly to this daemon, and I can store data in the daemon. So so I think so I'm just going to create a file with a text file. So hello world. So that's just a text file in my workshop directory here. And I want to add it to IPFS. So I can just go IPFS add hello.txt. And when I add it, it's a very small file, but it gives me this content identifier back. So this is really because now any other IPFS user in the world can get this content and identifier and see this file I just added, the contents of the file I just added. So if I did IPFS cat and just this there. So even if I remove the file, if I go cat, it's been stored in my computer. Now the neat thing is to demonstrate this, there's something we call the IPFS public gateway. And if you go over to IPFS.io, that's the main website. If I do just /IPFS and the CID, it will go, it takes a little while, but it's going to try to find my computer. Oh, there, so it worked. This is called a content identifier, and if you were on a different computer and you added the same file to your computer, it would when you added it, it would come up with the exact same content identifier here, because it's basically a content hash. So I don't know how much I have to explain content hashing, or are people they're familiar with cryptography content hashes? Because if I could explain that a little bit more, if
I think that would be worth exploring a little bit.
Okay, so in a hash is just a function that takes a long string of bytes and returns a smaller number, which whatever, if you ever give it the same long string of bytes. So if there's several common hashes. So let's see, I lost my hello world. So where was it? Oh yeah, so there's that one. So if I just put it back out to my disk here, on a Mac you can do MD5 hello.txt, and you would get this thing. If I copy it to another file, the file is the same. So if I go the same, if I change, or sorry. So hello2.txt has the exact same content hash as that one. If I modify even a single byte of it, I get a different content hash. So there are different ones. So there's a whole bunch of ones that are built right into the Mac here. So I can go SHA-256, and you get a different style of content hash. So this is essentially what a content identifier is it's generating a content hash, and it's adding a little bit of extra information and encoding it. Now, when you see the IPFS IDs, so content so like this long number. Let me just do. Okay, here's a content hash. This is actually called a multi-hash. So if I go to multi-formats.io, we have a bunch of different what we call the multi-formats. A multi-hash is what we call a self-describing hash. And so basically all it's doing is it's taking the type of the hash. So you can see here, I did an MD5 hash or a SHA-256 hash, and it's just going to encode that. And then it's going to encode the length and essentially the value. And then it puts it into a string, which is short and just uses printable characters. And that's what we call a multi-hash. They're nice because they sort of self-describe. Like when I get one of these hashes, I don't have to know whether it's a SHA-256 or MD5 or a Blake hash. It's encoded right in the string. So do people understand what I just said?
Someone said in the chat, yes.
Okay, so everything in IPFS is built around these multi-hashes, or it's just basically content addressing. So people can like I've copied hello.to.text. When I put that into the here, there, that resolved quickly. It's got the extra thing. Now the public web gateway has a copy of those bytes. People all over the world could, on their own IPFS nodes, fetch this content, and they will have a local copy of it. And they don't have to worry, like it doesn't need to be signed or anything, because the content identifier guarantees that it is the content that it refers to. So that has some very nice properties in that you can basically take any data structure and create all these hashes and distribute them globally. So
there's a quick question in the chat. So if someone else puts hello world, it will show the exact same hash?
Correct. So, and as long as the exact characters are there. So, and the nice thing is you can also do, so I just showed like the basic thing is just a single file, but you want to make a directory. And like I might have something from my pictures directory, say picture of my dog. And then maybe let's copy in those two hello. So I've got these 3 files in my directory. I can just go IPFS add -r, which stands for recursive dot, and it doesn't matter how many times you run it. You're always going to get this the same content hashes. So now I put all these files in here. I can click this, go over to the public gateway, and so, and you can see this is the whole directory is there. It has been exported now. So you can see hello text. Here's a picture of my dog. So that was really easy. These directories can be, and this is called, it's basically just a bunch of nested objects. So so each of these files could be retrieved individually and just get the content. But you can get this one, and it'll have the directory that wraps it all. And you can actually, there's some more command line internally. So, okay, so there's the IPFS get command if I wanted to say I didn't have that directory anymore, but I have this ID, and just IPFS get, and then it just it doesn't know the directory name, but if you go into it, there's all my files again. So I could go do this on another computer, and that would work anywhere in the world. So we have this, I'll just add it quickly. So you see the root hash here is this one. I can inspect, there's a bunch of commands here. So I think I've shown init, add, cat, get. You can inspect the data structures. So if I want to see the, I think I can go IPFS files, ls, and that hash there. Oh, it's probably slash. Oh, sorry, that's a different one. IPFS. I think I want object.
Hey, Jim, there's a quick question in the chat. How does hashing work with images? If the pixels of the same image are different, would that produce two different hashes?
Yes, definitely. So even a single bit difference should generate a completely different hash. And that's a property of cryptographic hashes, is you can't really guess what the original content was. So, but the, you could have a million bytes in a file, and you get a short little hash. But the probability of what they call a hash collision, so of two different images having the same hash, are very, very low, because there's still a lot of bits in the hash. So, so that means that you can just use the hash to sort of do the reverse lookup and find the original image. And it's very, very difficult to create for example, take two different images and have them have the exact same hash. It's really, really computationally intensive, and some of the weaker hash functions, such as MD5, have vulnerabilities that were exposed years and years ago, where that is possible, but with the stronger hash functions, it's not really possible on modern hardware to maliciously have two files that have the same hash. So that makes the, it is theoretically possible, but it's really, really difficult to figure out how to do that. So in practice, you can use the hashes as a content identifier to look up content and be pretty sure you're going to get the file that you put in there in the first place. So, okay, so I'm going to, okay, that's what I want. So you can sort of pull back the covers on there. So when I put the directory in, it stored 3 files, so hello.txt, hello2.txt, and the image of my dog here. And I can dump out the raw object with this IPFS object get, and you give it the hash. And the top level hash is just a wrapper that has this data structure in it. It's actually stored as a binary, but when you do IPFS object get, it'll dump it out as a JSON object. And you can see the sub-objects here. So there's hello, and each of the sub-objects have a hash too, which you saw when we did the IPFS. So if I add the whole directory again, you'll see hello.txt has that hash. And then I can look at the IPFS object get. I just want to look at that one internally. I can inspect that one too. And you can see this particular one is just a little text file. It's just storing raw data, and you can actually see hello world right in there. If I did that one on the file, the image file, it's going to look like that. Which, but there's lots of these little commands built into the IPFS command itself to see internal structures. So there's an IPFS block. There's a so IPFS object is sort of the older version of the IPFS internals, and there's a new version called IPFS or IPLD, which is interplanetary linked data. So it's pretty similar to what you just saw, but it's storing data as a directed acyclical graph. So let's see if there's a whole marketing page for that called ipld.io. And this explains it a little bit. So they're calling it the data model of the content addressable web. Allows us to create all hash-linked data structures as subsets of unified information space. And what the core idea is, just like when I showed you, something like that. I could actually do IPFS dig get, and it gives you actually almost the exact same data, but with the directed acyclical graph. It's essentially turning IPFS into a graph database where you can insert sort of vertexes of a graph and then little connections between the graphs, and query it. So I should probably stop here and see if there's any questions.
There's one question, and it's is it possible to cloning the directory or having a copy of directory content to local IPS folder or sync?
To clone a local directory?
Clone the directory or having a copy of directory content to a local IPFS folder.
So I put these 3 files in here, and I can clone that on a different machine. So like if I just say log into my laptop, I can go IPFS get that, and that will clone the data. So those files are now on a different machine. So we can clone things that way. So as long as you have the hash, you can clone that really anywhere in the world. Does that answer the question?
Yes. If you add a file to the folder, does the hash of the folder
Yes.
change?
So if I go IPFS add-r right now, you see the folder, this, maybe I'll just rename this so it's not so confusing. So and you'll see that that was the same hash we had before. If I now we have an extra file, and then I have to add R. So this is no longer this. So it used to be that one, and that was the had 3 files in it. Now that it's got 4 files, it has a different content hash for the wrapper. But each of the individual files has the same hashes as before. So, and in this case, you see hello2 and hello3 had the exact same content. So they have the exact same hash. And you can see the difference, like if you go IPFS object get, the first one, and then if I do with the so that particular, these data structures are different, so they'll have different hashes, and so the identifier is different. So
will the previous hash function value still be accessible?
yes. So when you do IPFS add, it's taking this file and it's putting it into the daemon, which is running right here, and it's actually storing it in the IPFS directory. So it's not really much to see in there, but there's a data store directory. It's just big binary blobs, but it's basically dumping the data into there. And so as I add more and more content, this will get bigger and bigger and bigger, and it'll keep all the files around. There's a command called IPFS pin, and if you do IPFS pin ls, when you add things, it adds it gets pinned to your inside your local data store on your peer, and what that means is it won't get removed. So when I do, like, say IPFS cat on somebody else's file from on a different peer on the internet, you know, put your CID. I don't know one off the top of my head. It will actually. I think that's what maybe what the indirect ones. I'm not good. Yeah. So there was one when we did the README at the beginning, but it'll fetch the content from other peers in the IPFS network and copy it to your local machine, but it won't pin that data. So what that means is if you don't use that data for a long period of time, it'll erase that off of your hard drive and reclaim that disk space. But every time you add data locally, it will pin the data. So, and so we can see, like, we pinned, I'll just grab the files here. So pin that one, and then we also had this one. So that was here. Now, say I want to free up the disk space that was used by this old one, the JSU, I could just do IPFS pin RM. Sorry. And then it's gone. But I can probably still fetch that because I fetched it to my laptop, and my laptop will have a copy of it. And the IPFS public gateway probably still has a copy of it cached. So it's pretty neat that way because the data becomes like really resilient. It tends to be long-lived. But it's still, if you want to keep data alive for a long period of time, you really do have to pin the data yourself in your own IPFS nodes you control. If it's public data that a lot of people are using, it's likely that they also have a copy of it, and you might not have to do that. So is that clear?
Can you choose the hashing, or is it MD5 by default?
You can actually choose the hash. So let's see if I don't. So if I go, it's not MD5 by default. I'm not actually sure what the default is. So I think if there's some command line options here. So oh yeah, so here's the hash. So default is SHA-256. So let me try different ones. So if I go dash hash. Let's try. I'm not sure which ones it supports actually. No, maybe I'm doing. So, oh, it's a SHA-2-256. So let's see, just try different. So yeah, so like here I used a different hash function, and it's a much longer string. The other thing that people are going to encounter soon is these. The string is encoded. It's a binary file, but it's encoded in an ASCII string, which means you have to sort of use readable characters to print it out. Sorry, was there a question or?
No, I think someone joined and their microphone was not muted.
Okay. So we're going to be doing a transition. So there's a tool here, so I can take so we have this hash here, and it's encoded using, if you look at it, it starts with QM. It has uppercase letters, has lowercase letters, has like numbers 1 to 9. And that's called base 58, because there's 58 different characters that the binary can be encoded with. But we're going to be switching to base 32. So I can do CID base 32. This is just a conversion utility. And it's basically, it's the same binary structure underneath. But the problem with our base 58 instructions is we use uppercase and lowercase characters. The problem is if we want to use them in DNS entries, so as parts of domain names. We can't do this because DNS is case insensitive. It doesn't know the difference between uppercase and lowercase. So we're going to be switching to a base 32 encoding, which if you look at the string, it's actually the exact same information in it, but it doesn't have any uppercase characters. It's all lowercase characters. And so it's got 32 different characters that are used. The downside is it's going to just, the identifier, or the hashes are going to be a little bit longer. So in binary format, it's the same number of bytes, but when you put it in ASCII format, it's a little bit longer. Yeah. But this can be used in DNS. So that's the reason we're going to be switching to these by default. So it's a little hard to understand. So there's the encoding, which is like what sort of characters are used, and there's the hash function itself, which are different cryptographic techniques. Does everybody understand that difference?
Doesn't seem to be any questions in chat about it, so I would assume so.
Okay, let's see. We spent a lot of time on the command line here. I'm just going to see if I missed everything. Probably. So I think I covered basic putting data in and getting data out. I showed you a bit of how you can sort of see the internal structures of it. One part that's probably important to understand is the networking aspect of it. So I showed you IPFS ID before, and this is what the peer I created is being identified to the world as. And it's listening on some ports on my local network. And it's also got it's also figured out how to get out through my firewall. So this is actually my home IP address. And it's, so these addresses you're seeing are called multi-addresses, or multi-adder, which is another one of those multi-formats. It's basically a way of saying, putting all the information you would need to contact this peer-to-peer node on the network in one string. So this says using IP version 4. So this is on my local network, IP version 4. This is the IP address behind my firewall of my iMac. And it says it's listening on TCP port 4001. And there's an IPFS peer listening on it. And this is the public key. So with all this information, any other IPFS node could talk to it, providing it's on my local network behind my firewall. These particular ones are using ports that are outside my firewall. So if I was forwarding the ports to my local iMac behind my firewall, and I'd have to go to my firewall and set up port forwarding. They could talk directly to me. But not everybody is going to want to configure their firewalls to run IPFS. But IPFS is peer-to-peer, like BitTorrent. So like so there's IPFS swarm command. So when IPFS starts up, in addition to listening to some ports, it tries to connect to a bunch of what we call bootstrap peers. And I'll just show you. There's an IPFS configuration file, and if I scroll down here, it's going to have pre-configured a bunch of public, we call them bootstrap peers that are run by Protocol Labs. And they're scattered all over the United States. And it will go and talk to these peers and their different computers. And they'll start gossiping. And from those first set of peers, those peers will then say, hey, you can go talk to more peers. And so what happens is your local daemon that you're running here is actually talking to hundreds of computers. So you can see them by typing IPFS swarm peers, and you'll see this is talking to a lot of computers all at once. And I can actually ping any of these, so I can take just I have no idea who this is, but I can just go IPFS ping, and luckily I'm pinging some random computer out on the internet, and you can see that it's responding. I'm going to introduce quickly the IPFS desktop. So are people clear with the idea of the peer-to-peer networking here?
Yeah, I think that we're good to move on to the IPFS desktop.
Okay, so IPFS desktop is a downloadable sort of GUI for IPFS, and you can actually use this instead of the command line, although if you install it, you don't get the command line tools. And I'm just going to stop this one, and I already have it installed. Actually, I'm just going to show you where to download it first. So just search for IPFS desktop. And you get it on GitHub, and it gives you this little GUI command line. And I think this will eventually become the primary way people install IPFS and run it. So I'm just going to use IPFS desktop to start an IPFS node. And it's basically running IPFS daemon for me. So I can still do IPFS ID. So I'm connected to it now. And the nice thing about IPFS desktop is it has a GUI built into it. So you can go status. Okay, so I'm going to shrink it. And you can see, click on peers, and here's a little map of the world. You can see it just started up. It's going to start to connect to a bunch of different peers. There, see, it's gone 48 peers. And it shows you where they are on the map. It also gives you a bit of a GUI, like you can actually put your files in here. So if I want to add to IPFS, I can just use instead of using the command line, I can just
Are there any APIs for the desktop GUI?
So the desktop GUI is just basically talking. It's actually just running the IPFS daemon behind the scenes. So you can talk directly to the API that it's running. So like here's this one. Let's see. Can I get the copy hash? So I can just go here, IPFS get that, and you see that was the image there. So this it's just basically like a nice wrapper around the daemon, and it also shows you things like your traffic usage, incoming, outgoing, and it's updated in real time. You can click and expand things, and you can also so like when we did IPFS add. So when I did IPFS add.r, it's just talking to the daemon, but the daemon's being run but inside the GUI here. So I can actually explore graphically. So this is my directory with the hello, 2.txt, hello, 3.txt. And I can click into these and expand them. So you can actually see, it's really the same things as you could get from the command line tool, but it's more graphical. You can add connections here. So say for some reason it wasn't finding my laptop on the network, the IPFS node running on I can just go IPFS ID. So this is a separate computer. This is my laptop. I've got this here. I can just go here, add connection, put that in there, and it will successfully connect to my laptop. I could have just done that as well by doing, this is back on my desktop here, IPFS Swarm Connect. That was just a wrapper for this tool. And that means I can ping that directly. So even if I wasn't connected directly to, like if it wasn't maintaining a connection directly to my laptop, I could still sort of retrieve content on that laptop, because that laptop is talking to hundreds of other nodes at the same time. And they sort of gossip, and there's something called the distributed hash table, which allows peers to find each other and allows them to find content. So, so this should give you, at least visually, an idea of what's happening. So, like that's a lot of connections. There's not a lot of traffic going over those connections, but each peer maintains. There's hundreds of thousands of IPFS peers running out there in the world, and each one is connecting to hundreds of peers. So there's really good connectivity, and it's really, really hard to take the IPFS network down. So.
Hey, Jim, we're closing up on an hour here. Can't thank you enough for doing this presentation. It was super in-depth and very, very helpful. Where can people find out more about IPFS and about you? Okay,
so IPFS, just go to ipfs.io and go down there. I'd recommend starting reading through the documentation guide if you want to get into the low-level stuff. There's a lot more I hope to cover that I didn't really have time for, such as there's an IPFS companion, which allows you to run, it's a browser extension that you can run inside the browser itself. There's a full set of programming APIs. You can program, there's implementations in Go as well as JavaScript. There's a full version of IPFS that's built using JavaScript. It runs in Node.js. And there's sort of sister projects to IPFS, such as Filecoin, which is sort of a new blockchain, which is going to enable people to sell and buy storage globally and store large amounts of data for really, really cheap.
Great.
And for me, you can always get me at jimpick.com. I've got all my, I haven't blogged for a while, but I have all my links there, and you can find me on, I don't really use Twitter much, but you can find me there. I'm just Jim Pick everywhere, so.
Awesome. Jim, thank you so much. Really appreciate you taking the time out to run this. Super helpful. And yeah, thank you.
Okay, thanks for having me. And everybody try it out, it's fun.
Have a good one.
Okay, bye.